The global tire industry is enormous. We're talking about a market worth over $142 billion as of 2024, and it's on track to hit more than $211 billion by 2032. Every day, millions of cars, trucks, and buses rely on just 4 black circles to stay connected to the road. We trust them with our safety when we're flying down the highway or slamming on the brakes, but we rarely give them a second thought. They are arguably the most critical safety feature on any vehicle. Yet for most of us, how they're made is a complete mystery. Have you ever wondered how a pile of raw rubber and a long list of chemicals turns into the high-performance link between your car and the pavement? What really goes into engineering a product that has to survive brutal heat, freezing cold, and constant abuse for tens of thousands of miles? The scale of it all is mind-boggling. The industry is expected to churn out over 22 million tons of tires every single year. Today, we're going inside a mega factory to see one of the most complex manufacturing processes on the planet. We'll follow the journey of over 200 raw materials as they're transformed by giant machines and skilled workers into the high-tech rubber that keeps you safe. This is how car tires are made. Chapter 1. The Symphony of Raw Materials. Creating a modern tire is like a form of industrial alchemy. It all starts with a surprisingly diverse cast of ingredients sourced from all over the world. While we just see a black rubber ring, the reality is a sophisticated recipe where every single ingredient has a specific job. And that recipe is a closely guarded secret for each manufacturer. Believe it or not, the journey doesn't start in a factory, but on quiet, humid plantations in places like Malaysia and Indonesia. This is home to the Hevea brasiliensis, the rubber tree. Workers make precise cuts in the bark, a process called tapping, to let the tree's milky white latex drip out into collection cups. This raw latex is then gathered, treated with acid to coagulate it, rolled into sheets to squeeze out water, and then dried. This natural rubber is prized for its incredible elasticity and low heat buildup, making it an irreplaceable part of the final product. But natural rubber alone can't handle the stress of modern driving. It has to be blended with synthetic, man-made rubbers that come from petroleum byproducts. The most common types are styrene butadiene rubber, SBR, and polybutadiene rubber, BR. SBR is fantastic for abrasion resistance and wet grip, which is why it's a key ingredient for the tread. BR, on the other hand, offers great resilience and low rolling resistance, which helps with fuel efficiency. By blending these with natural rubber, engineers can fine-tune a tire's performance for any condition, from scorching summer heat to sub-zero winter cold. The thing is, rubber by itself is pretty weak. It would wear out in just a few miles. The ingredient that gives a tire its black color and its incredible strength is carbon black. This fine black powder is basically a highly engineered form of soot made from burning petroleum products. When it's mixed in, the microscopic particles create a reinforcing skeleton inside the rubber, making it dramatically stronger and more durable. It also protects the tire from UV radiation and helps pull heat away from the tread, preventing it from overheating. Lately, especially for green and EV tires, another ingredient has become just as important: silica. Often derived from rice husks, silica is a high-tech alternative to carbon black. It's a game changer because it significantly lowers rolling resistance, meaning better fuel economy or longer battery range, while also boosting grip on wet roads. Many high-performance tires now use a carefully balanced mix of both carbon black and silica to get the best of all worlds. On top of all that, a complex cocktail of over 200 other materials gets added in. You've got antioxidants and antiozonants to protect the rubber from breaking down in the atmosphere. There are also special oils to make the compound easier to work with. And, most importantly, there's the curing package, a small but vital amount of sulfur and other chemicals. They won't do anything just yet, but they hold the key to the tire's final transformation, which we'll see a little later. Chapter 2. The Art of the Mix. Creating the compounds. Once all the raw materials are ready, it's time to mix them into the specific rubber compounds for each part of the tire. And you can't just toss everything in a bowl and hit blend. It's a highly controlled process that happens inside one of the factory's most powerful machines, the Banbury mixer. Think of a kitchen mixer, but make it absolutely massive, with enough power to churn hundreds of kilograms of dense, sticky rubber at once. Inside its enclosed chamber, two huge interlocking rotors spin in opposite directions, kneading and shearing the materials with incredible force to make sure everything is perfectly blended. The process kicks off when bales of natural and synthetic rubber are dropped into the mixer. As the rotors break them down, a computer system adds the other ingredients in a precise sequence. In go the reinforcing fillers, carbon, black, and silica, along with various oils. The intense friction and pressure generate a ton of heat, raising the temperature to over 150 degrees Celsius. This helps create a single, uniform, black, gum-like mass, called the master batch. This process is repeated to create different recipes for different parts of the tire. A single tire can use up to 10 unique compounds. The tread compound is all about grip and durability, while the sidewall compound needs to be flexible and weather-resistant. The inner liner, which holds in the air, is made from a special, super-impermeable butyl rubber. But there's one thing they deliberately leave out. The curing agents, like sulfur. If they were added at this high-temperature stage, the heat would trigger vulcanization way too early, hardening the rubber right inside the mixer. That's called scorch, and it would ruin the entire batch. So, after the master batch cools down, it's sent back for a second, lower temperature mix. This time, the curing agents are added. The mixer runs for just long enough to distribute them evenly without kicking off the chemical reaction. As each batch comes out of the Banbury, it's a massive, steaming hot slab. It's then dropped onto roller mills that squeeze it into a thick, continuous sheet, which also helps it cool. Finally, the long sheet is hung in wavy folds from an overhead conveyor, a pattern called a wigwag, to let air circulate and bring the temperature down. Once cooled, it's cut into slabs, coated and stacked, ready to be made into the tire's components. Chapter 3. Building the bones. Component creation. With all the different rubber compounds mixed and ready, the factory can now start making the individual parts that will come together to form the tire. This is where we see raw material turn into precisely engineered pieces, each with a critical job to do. Let's build a tire from the inside out, starting with the inner liner. This is the tire's first line of defense against air loss, essentially a built-in inner tube. It's a thin layer of a special butyl rubber that's extremely resistant to air. This compound is fed into an extruder, which heats it and forces it through a die to create a wide, thin sheet. Next up is the carcass Pleissanthus, which is the skeleton of the tire. It's made of a layer of fabric cords, usually polyester or nylon, sandwiched between two thin layers of rubber. This fabric is run through a massive machine called a calender, where heated rollers press rubber into it from both sides, coating every single cord. The resulting sheet is then cut at a very precise angle, which plays a huge role in how the tire handles. At the same time, the tire's anchor is being made, the bead. This is a pair of strong hoops made of high-tensile steel wire. These wires are coated in bronze to help them bond to rubber, then wound into a bundle. This loop is then covered in a hard, stiff rubber, which will hold the tire tightly against the wheel rim and create an airtight seal. Then you have the sidewall. It protects the carcass from the side and gives the tire the flexibility it needs for a comfortable ride. It's also where you find all the information about the tire, its size, speed rating, and brand name. The sidewall compound is made to resist flexing and cracking, and it's created in an extruder with a complex die that imprints all the lettering as it's formed. Now for the tires. Hidden armor. The steel belts. In a modern radial tire, these belts provide incredible strength and puncture resistance. It all starts with thousands of spools of ultrafine steel wire. These wires are perfectly aligned and fed into another calender where they're encased in a sheet of rubber. This sheet is then cut at a sharp angle, usually around 20 degrees. Two of these layers are used, placed on top of each other so the steel cords form a crisscross pattern. This triangulation makes the tread area incredibly rigid and stable. And finally, the part that actually touches the road, the tread. The tread compound is warmed up and pushed through an extruder with a specially shaped die. At this point, it's just a long, smooth strip of rubber, known as a tread slab. The familiar grooves and patterns haven't been added yet. That happens in the final step. With the inner liner, carcass ply, beads, sidewalls, steel belts, and tread all fabricated, so the stage is set for a truly remarkable robotic performance. Chapter 4. The Robotic Ballet, Automated Assembly. The heart of the tire factory is the tire building machine, or TBM. This is where all those separate components are, brought together in a synchronized robotic ballet to form what finally looks like a tire. The whole thing is a masterclass in automation. It all starts on a rotating, collapsible metal drum. First, a robotic arm wraps the sticky inner liner around the drum, followed immediately by the carcass ply. The edges are automatically stitched down to ensure a perfect bond with no trapped air. Next, robotic grippers place the two bead assemblies onto the outer edges of the drum. Then, in a key moment, inflatable bladders on the drum expand, forcing the edges of the carcass ply up and around the beads, wrapping them securely. At the same time, the pre-made sidewalls are pressed on, and rollers stitch everything together into a strong, unified structure. What we have now is the basic donut shape of the tire. This whole structure is then moved to a second shaping drum. Here, the drum expands from the center, pushing the carcass outward into its familiar rounded profile. As it expands, the tire hidden armor is applied. A transfer ring lays the two steel belt layers onto the crown of the tire, making sure their opposing angles are perfectly aligned. On high-performance tires, a nylon cap ply might be added on top for extra high-speed stability. Finally, the tread slab is wrapped around the circumference of the steel belts. With all the layers in place, a series of stitching rollers descends, applying immense pressure from the center outwards. This squeezes all the layers together, forces out any trapped air, and ensures everything is bonded into a single piece. The entire assembly is a marvel of efficiency, with some machines building dozens of tires an hour to within 1/10 of a millimeter. The product that comes off the TBM is called a green tire. It looks like a tire, but it's not ready for the road. Its surface is smooth, and more importantly, the rubber is still soft, sticky, and weak. It's an assembly of perfectly placed parts, waiting for its final, transformative trial by fire. Chapter 5. Trial by fire, vulcanization and curing. The soft green tire now moves to the most critical stage, vulcanization. This is the chemical process that will turn the weak rubber into the strong, elastic material we all know. It happens inside a curing press, which is basically a giant, high-tech waffle iron. Inside each press is a heavy, two-piece metal mold. The inside surface is a perfect negative of the tire's final design. Every tread block, every rain groove, and every symbol on the sidewall is engraved into the metal. The green tire is automatically placed into the bottom half of the mold. A flexible bladder descends into the center of the tire, and the heavy top half of the mold closes. sealing it inside. Then, the transformation begins. The mold is heated to around 170 degrees Celsius, while superheated steam or hot water is pumped at high pressure into the internal bladder. The bladder inflates powerfully, pushing the soft rubber into every last detail of the engraved mold. But the real magic is happening at a molecular level. The heat and pressure finally activate the cure package, the sulfur, that was added back in the mixer. Think of the rubber molecules as a bowl of uncooked spaghetti, where the strands can all slide past each other. The vulcanization process is like cooking that spaghetti. The sulfur atoms create chemical cross-links that stick all the polymer chains together into a fixed, interconnected network. This cross-linking is what completely changes the rubber's properties, turning it from a plastic-like material into an elastic one. It's what gives the tire its strength, resilience, and durability. The process is irreversible. This intense cooking, named after Vulcan, the Roman god of fire, takes about 10 to 15 minutes for a passenger car tire. The timing has to be perfect. Once the cycle is complete, the press hisses open and a robotic arm pulls out the finished tire. It's incredibly hot, and the air is filled with that distinct smell of freshly cured rubber. It's no longer a soft green assembly. It's a fully formed, robust tire, ready for its final exam. Chapter 6. The final inspection, the pursuit of perfection. A tire is a critical safety item, so its journey isn't over just yet. Before it can be shipped out, every single tire goes through a tough, multi-layered quality control process, a blend of high-tech machinery and expert human oversight designed to catch the tiniest flaw. After leaving the press, the hot tires cool on a long conveyor. The first stop is a trimming station where tiny rubber hairs, left over from vents in the mold, are quickly shaved off. From there, the tire enters the inspection zone. First, it's mounted on a test wheel and spun at high speed while sensors measure for any force variations or imbalances that could cause vibrations on the road. Any tire outside the very tight tolerance range is immediately rejected. Next, the tire gets an X-ray. Just like a medical X-ray, this allows inspectors to see deep inside the tire structure. They're looking for hidden flaws like air bubbles, misaligned steel belts, or any foreign objects. Any internal issue, no matter how small, is grounds for rejection. Some factories even use laser systems called shearography to create a 3D map of the tire's surface and subsurface, detecting tiny separations the human eye or even an X-ray might miss. But even with all this technology, the process isn't complete without the final human touch. After the machines are done, every tire still gets a visual and tactile inspection from a highly trained worker. They run their hands over the entire surface, feeling for bumps and check the inner liner for any defects that could cause a slow leak. Their experienced eyes and hands are the last line of defense in the factory's pursuit of perfection. Only after a tire has passed every single one of these checks is it finally deemed ready for the road. It gets a barcode linking it to its full production history and is then automatically sorted, stacked, and prepared for shipment. From a drop of latex in a forest to a complex structure of over 200 materials, the journey of a car tire is an incredible testament to engineering, chemistry, and automation. It's a wildly complex process, all to create something most of us take completely for granted. So that brings up a question for all of us who drive. Do you think most drivers really appreciate how important their tires are, or are they just ignored until something goes wrong? Let us know what you think in the comments below. And if you found this look inside the world of manufacturing fascinating, hit that like button and subscribe so you don't miss our next deep dive into how the world around us is made. What started as white liquid dripping from a tree has been completely transformed. It was mixed with synthetic polymers and reinforcing fillers like carbon black and silica to become a suite of high-tech compounds. Those compounds were built into a skeleton of fabric, steel, and rubber, assembled with robotic precision into a green tire, and then forged into its final shape and strength by intense heat and pressure. Finally, every single tire was inspected to ensure it was absolutely perfect. The next time you get behind the wheel, take a moment to look at those 4 black circles your car is resting on. They aren't just simple pieces of rubber. They are marvels of modern engineering, the result of a global supply chain and one of the most sophisticated manufacturing processes on Earth. Each one is a promise of safety and performance, a complex product hidden in plain sight, connecting us to the road and carrying us safely where we need to go.